Hello, my name is Venelin and I work for Intiquan, a company that specializes in high-quality data analysis and consulting services for pharmaceutical projects. Mixed effect models are the de facto standard modeling framework for clinical trial data. Once a model is fit to the data, we simulate this model to predict various quantities of interest. However, the simplest approach of simulating a model using point parameter estimates to deliver a point prediction is rarely acceptable by today's standards. Rather, we need prediction intervals, taking into account the parameter uncertainty, the covariate effects, the inter-individual variability, and the residual error of the model. This is accomplished by simulating multiple times, each time using a randomly sampled set of model parameter values. And so, the random sampling of model parameter values based on the estimated uncertainty, variability, and covariate distributions becomes an essential prerequisite for the simulation. But there is a major problem in the fact that there are multiple formats of reporting parameter estimates, whether this is in the literature or in the tools we use to estimate mixed effect models. This current lack of standard format for reporting parameter estimates presents a challenge for the communication, reproducibility, and quality assessment of modeling projects. Addressing this issue, Intiquan proposes a human and machine-readable general parameter format, which I'll be calling GPF, as well as a handful of supporting R functions in IQR tools. IQR tools is a software framework developed at Intiquan to support ourselves and our customers in all of our modeling and simulation activities. So, what is the GPF? This is shown in the mid-bottom panel. The GPF is a simple human and machine-readable Excel file containing all information necessary for the sampling of mixed effect model parameters. In particular, this includes the fixed effects and their uncertainty, random effects, their uncertainty and distribution, the correlation of the random effects and its uncertainty, covariates, coefficients, relationships, and reference values for the covariates. The main advantage of the GPF format is that the Excel file is ideal as a supplement in a publication or a modeling report, as well as an input for a parameter sampling program. Furthermore, we are continuously implementing functions in the package IQR tools that automatically export to the GPF the results from the most popular model estimation tools. The bottom left panel describes in mathematical terms how IQR tools implements the sampling based on the information found in the GPF file. This is implemented in the function sample GPF. To demonstrate our approach, we created a case study using a drug-drug interaction PK/PD model published previously in the literature. The top middle panel shows the structural model and the parameter estimates reported in figures and tables in the paper. Our goal for this case study is to use the GPF and the sampling function in IQR tools to reproduce some of the figures in the paper, showing the typical parameter values corresponding to specific demographic covariates and simulated PK/PD profiles. We do this in 3 steps. First, we manually export the parameter estimation table to the GPF. Automatic export was not possible here because the model estimation tool and the raw estimation results are not available in the paper. Next, we use the function sample GPF from the IQR tools package to calculate typical parameter values and to sample from the inter-individual variability distribution. And finally, we call the function sim-IQR models from IQR tools to simulate individual PK/PD profiles. In summary, the GPF greatly simplifies the specification and manipulation of mixed effect model parameters. The R package IQR tools provides a set of handy functions enabling the automatic export of various parameter formats to the GPF. The adherence to a common model parameter format enables a unified approach to the model parameter sampling and simulation, thus contributing to the reproducibility in pharmacometric research and development. With that, I'd like to thank all collaborators and co-authors of this project. And thank you as well for stopping by.